In this lesson, we shall focus on WTW158, calculus, limits, derivatives, integrals, and a lot more. We're getting started right now to solve past exam questions during the course of this lesson, and we proceed as follows. Right, so we're looking at the WTW 158 2022 exam multiple choice questions. Each question is worth 1.5 marks. Question 1 is as follows. Now, the largest interval on which the function f of x equals the square root of x minus 2 minus the square root of 3 minus x is continuous is what? You have the largest interval on which the function is continuous. Which is which? Right, so let us look at that one. And to do that one, we need to look at the largest interval. So to get the largest interval, the couple of things you need to take into account. First things first, we realize that we have x minus 2, which must be greater or equal to 0, simultaneously 3 minus x is greater or equal to 0, like so. Okay, because it is continuous whenever the domain of this function is the correct one. Okay, right, at this point, we transpose the 2, and with x is greater or equal to 2, but simultaneously, it follows then that minus x is greater or equal to minus 3. Upon careful exam, with this one, you divide by minus 1, and this one you divide by minus 1, which means that x is less or equal to 3. Now, we take this and we have a number line here, and we have 2, and we have 3 on the number line, and this is the number line of the values of x. X is greater or equal to 2, and we're going to move in this direction. And we then say, but x is less or equal to 3, like so. Upon careful examination, we are then saying, this must be true, and this has to be true. And the conclusion is as follows, that our solution is going to lie between these two extremes, and therefore we have 2 less or equal to x, less or equal to 3. And this, therefore, is the answer. If you do not want to write the answer like this, you then say x is an element of the closed interval from 2 to 3, like so. And most importantly, we can write here with only commas. Okay, you see, in school, we write it differently, but at university, we write it differently. Right, our curriculum, our curriculum needs to be restructured very seriously to ensure uniformity in school and university. But you really can see here, the examiner is using commas all the way. But in school, hey, if you use a comma, 2,3 is what? In school, is a decimal. Okay, in school, 2,3 is a decimal, but here, this means an interval. So that, the largest interval possible, and therefore the largest interval possible, the correct answer is F. Any question on this one there? We shall go through a wide range of questions, limits and more, functions and whatever. Right, any question on this one, Atlahong?
No.
No question. We proceed. Thank you. Okay, question 2 is on limits. We have a limit question. So given the limit, might be small, but we're just taking from the past exam. So you have the limit as x approaches negative infinity of arc tangent of 4x. Right, let me give you 1 minute to try this one, then we discuss together. Right, what do you think is the answer to this question? I'm giving you like 1 minute, and then we discuss together. Some of this you might have seen, so maybe you'll just remember. Be like, the answer is this. You know? You'll be like, the answer is this. Right, please let me know when you're done.
Okay.
All right. Then we're going to discuss. I'm just going to give the answer anyway. Just going to give the answer. Just will give the answer. Right. Righty, right, righty, righty, right. Right, 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 right. Okay. Please let me know when you're done.
Okay.
All right, thank you. I know that I'm just ambushing you. It's not fair to you because I'm just ambushing you. I'm just bringing these questions. It's not fair. But I know that we're going to discuss in the end. Okay, you're like, okay, you did not even expect these questions. You did not. Now I'll be like, okay, now he's asking me these questions. What should I do? Maybe it's too tricky. It's too tricky. Okay, I want us to discuss something. Let me know when you're done because I've already given you a chance and you might be close and be like, okay, I want to share my answer. You'd be like, I want to share my story. Okay, there's something we call a diagram like this. Okay, I'll share the answer with you because I don't want you to take too long. Okay. Now if you have this, because the most I can give most of these questions are like it's like a minute, 2 minutes maximum. All right. So in the end, then there's something we call this particular graph here. Okay, please. We are looking at the graph of arctangent of x. And looking at the graph of arctangent of x, this is pi over 2 radians. This is negative pi over 2 radians. And the graph is actually like so. Okay, why? Because the tangent is an odd function. Right, so at the point that, for instance, you are able to then say there are particular given values of x such that you'll have certain outputs. Now, this relates to 10x equals y. The 10x equals y, you know very well that it is undefined at given numbers. Where is it undefined? Right, you know that at pi over 2, it is certainly undefined there, but also at minus pi over 2, it is surely undefined. Okay, so as a consequence then, what we're able to see, but also that at this point, for a given x value, this function is an odd function. So for a given x value, it is a positive x value here. Right, for x positive, y is also positive. Right, at this point, for x negative, y is negative. All right, so because of this, so this is the that sort of justifies this kind of a pattern. Right, but what happens when x now becomes, negatively infinite? So x now goes haywire, and here is x, and x approaches negative infinity. You can write like this, makes sense. X approaches negative infinity. So it goes to the negative end of this particular x-axis. The question is, what is the answer to this? Right, we're able to see, therefore, that the answer is going to be, as you approach the negative side, it gets closer and closer to minus pi over 2, which is negative pi over 2 radians. So which one, therefore, becomes the answer? Right, so the answer becomes B. Any question on this one at home? No question.
No.
All right, that's fine. We move to the next point. Right, we move to the next point. We need to determine the critical numbers. The critical numbers of the function f of x equals the natural log of x minus x. Now, if f of x equals the natural log of x minus x, what are the critical numbers? What are they? What are the critical numbers? What are the critical numbers? The critical numbers at this point are obtained as follows. Right, we found them last time and you can do them. So I'm not going to waste a lot of your time because this is a bit lengthy. But to find the critical numbers, we first find the first derivative. The derivative of the ln of x is 1 over x. The derivative of minus x is the -1. The critical numbers, now 4 critical numbers. For critical numbers, we put the derivative f prime of x, we equate it to what? We equate it to 0. But also we look at where f prime does not exist. Right, so we're going to look first at 1 over x minus 1 equals 0 in part 1. So we're going to call this one part 1, part 2. Part 1 is where we have this one, but here this one is 1 over x equals 1, and this means x is 1. Right, so now, simultaneously, we're going to be looking at the part where this does not exist. Where the derivative does not exist. Where does it not exist? It does not exist whenever the denominator is 0. Right, and we note that, of course, it's not defined when x is 0, but x equals 0 is not in the domain. Remember, we need to find the critical numbers, but x equal to 0 is not in the domain. Is not in the domain of f. Is not in the domain of f. Is not in the domain of f. So now, because x equal to 0 is not in the domain of f, means that you're going to pick 1, that is a critical number, so that now the only critical number there is c equals 1. What is the critical number? It's only c equals 1, which is part A. It's only c equals 1, which is part A. Any question on these, Atlahang?
No.
No question. Move on. Right, the equation of the tangent line to y equals x cubed plus 4 in the point where x equals -1 is what? Let us find the equation of the tangent line in the point where x equals -1. This one is like school. So now we have y equals x cubed plus 4. We have dy dx equals 3x squared. And want to find the equation of the tangent. The equation of the tangent is dy dx, and this is actually where x equals to -1. We have 3. Okay, 3, then we have -1, you square it. 3 minus 1, you square it, and the result is what? The result is 3. Now, at this point, it means, therefore, we are dealing with what? Okay, we found a slope, which is the gradient. And so now we note that there is also y equals -1 cubed plus 4, which is exactly 3. Now, this passes through right. So this passes through where x is -1, y is 3, which means you have y -1 m into x minus x1. Y minus 3 equals the gradient 3x minus 1, like this, which means y equals 3x plus 3 plus 3, which means y equals 3x plus what? 3x plus 6. Okay. And y equals 3x plus 6 corresponds to the option B, and therefore the option B is the correct answer to this one. And option B is what gives the correct equation. So the correct equation is therefore y equals 3x plus 6. Any question? No question. No. All right, good. Move to the next one. Consider the following statements with the natural log ln of AB squared equals 2 ln A, ln B, ln 3 is ln 6 minus ln 2. The ln of e to the power x equals 1. Choose the correct answer. Only statement 1 is correct. Only statement 2 is correct. Only statement 3 is correct. Only statements 1 and 2 are correct. Only statements 1 and 3 are correct. Only statements 2 and 3 are correct. Statements 1, 2, and 3 are correct. Statements 1, 3, and 1, 2, and 3 are false. What do you think of this one, Atlahan? Too easy. What do you think?
I think statement 1. No, statement 3
Remember,
is
okay, that's
correct.
fine. Okay, yes. Okay, let me write them in big because this typing was small. So 1 is like this. It says the ln of AB all squared is 2 ln A ln B. And then 2 is ln 3 is the ln of 6 minus ln 2. Number 3 says the ln of e to the power x equals what? Which one is the correct one here? Your take. You're saying something, right?
Mm-hmm.
Yeah, so what do you think? Okay, because we're just practicing here, but it's too easy, right? Okay, so this one, first and foremost, I'm going to do it in green color. I've already written this one. So this one is incorrect. Right, it is incorrect because we know that the ln of AB squared is 2 ln AB. Right, so if it is 2 ln AB, come on, it is not the same as this. So this one is incorrect. Next, this of number 2 is correct. Why? It is correct because the ln of 6 minus the ln of 2 is the ln of 6 over 2, which is ln 3. So this one is correct. Number 3, the ln of e to the power x equals 1. It's not the case. It's not the case because we know that the ln, so this one is incorrect. Why would this one be incorrect? Okay, so it is incorrect because of a wide range of reasons. It is incorrect because the ln of e to the power x is x ln e, but ln e is 1, so that you have by 1, and this is x. So ln of e to the power x is just x. It's not just 1. All right, so we good. Good. And therefore, the correct answer is what? Right, the correct answer is B. It's B that says only statement 2 is correct. So indeed, only statement 2 is correct, but statements 1 and 3 are incorrect. Okay, any question, any input here at your hand? Nothing. You're fine. It's too easy.
Yeah, I'm fine.
Okay, never mind. Okay, we're practicing here. Question 6. Question 6. Consider the following statements. Right, so we have the following statements here, and there I'm going to write them in big. I'm going to write them in big. So we have that number 1 says that if f of x is 3 ln x, then f primed is 3 over x. Okay, if f of x is 3 ln x, then f prime is 3 out of x. If f of x is the sine of 3x plus the cosh of, okay, these are the hyperbolic functions. I'm sure you might have seen them. Then the derivative of f, that is, which is f prime of x is 3 times f of x. Number 3 says if f of x, okay, so if f of x. Number 3 says that if f of x is this one, then f prime is 3 and this. So what is then the answer to this? What is then the answer to this? Okay, so the question is, consider the following statements. Choose the correct answer. The first one, only statement 1 is correct. B, only statement 2 is correct. C, only statement 3 is correct. D, only statements 1 and 2 are correct. E, only statements 1 and 3 are correct. F, only statements 2 and 3 are correct. G, statements 1, 2, and 3 are correct. H, statements 1, 2, and 3 are false. I hope you're able to see this one, Atlehang. Your input, your take on this one. Right. Your take on this one here. Your take on this one. Your take
I
on this one.
think
Yes.
statement 1 is correct.
Still thinking about it? Oh, you think number 1 is correct, you said. Okay, you think number 1 is correct. Okay, that's fine. Okay. Okay, you're not really saying A is correct, but you're saying number 1 is correct. All right, that's fine. So you mean this one is correct, right? So would say number 1 is correct, not really letter A. Right. What do you think about B? 2. What do you think about number 2? Is it correct or not? Okay,
It's
yeah, yeah, please come again.
I think it's incorrect.
Let's check it out. Let's check it out. Okay, so obviously, if you have f of x equals the hyperbolic sine of 3x plus cosh of 3x, then the derivative of these is 3 times that. So yeah, you'd say, let's start with f of x, which is the sine of 3x. The cosh of 3x. Then now you'd have f prime of x. The derivative of the hyperbolic sine is what? Is the cosh. And the derivative of the cosh is the hyperbolic sine. But remember that you're going to put 3 there because the angles, you need to use the chain rule. Right, the derivative of the hyperbolic sine is the cosh, but you put 3 there. And therefore now 3 can be taken out as a common factor, giving us the cosh of 3x plus the hyperbolic sine of 3x. Like so. Upon careful examination, we can see what is cos 3x plus hyperbolic sine, it's f of x. So that indeed it is correct to say f prime of x is that. So this one is also correct. It's also correct. So now, which means that option 2 is also correct. Let us look at the third one. Right, so the third one. The third one is as follows. Right, so the third one is as follows. Now, in the third case, you're going to actually take this function, which is f of x equals e to the power 3x, like that. Then we're going to find the derivative of, which is f prime of minus x. So now, what is f of minus x? E to the power minus 3x. F prime of minus x. which is actually minus 3e to the minus that. What is e to that? E to the power minus 3x. Right, okay, because if you have f of x is this one, the derivative is e remains e, and you multiply by the derivative of minus 3x, which is minus 3, okay? And then right now, you continue to then say, what is e to the power minus 3x? Right, so e to the power minus 3x becomes f of this, okay? Because f of minus x is e to the power minus 3x. What is the answer to this? What is the answer, therefore, to this particular expression here? Simultaneously, you can look at this like as follows and say the following. Let us take a look at it differently and say, one way to look at it is to say you have f of x equals e to the power 3x. What is f prime of x? It is 3e to the power 3x. That is the derivative. Meaning if you have f prime of minus x, it is 3e to the minus 3x, which is 3, the e to the power minus 3x is exactly f of minus x. Right, so meaning that the f prime of this is actually that. So meaning that 3 is also correct. Okay, so we have 3 correct ones. Right, so we have that this one is correct, 2 is correct, and also 1 is correct. Okay, so meaning therefore, at this point, we have that G is the correct answer. Statements 1, 2, and 3 are correct. Statements 1, 2, and 3 are correct. Any question here at Lehong? Any input, suggestion?
No.
No. Okay, good. We try question 7. Please try question 7. I'm giving you like 2 minutes. Maximum time, 2 minutes. You're right. You cruise quickly and tell me which one is the answer. Is it A, B, or, something else? And then when you're done, please let us know.
Okay.
Good, thanks. Right, let us know when you're done. Right, right. You let us know when you're done, and then we can discuss it. We can discuss it. We can discuss it. Right. How far? Okay.
Almost done.
All right, that's fine. You'll forgive me because I'm just not fair to you sometimes. Give you short time, like very limited time. It's not the most realistic of things. It's not the most realistic of things. Not the most realistic of things. Right. It's not the most realistic of things. Right.
I think the answer is D.
Okay, you think the answer is D. That's fine. We're practicing. If you think the option is D. Right, first things first, we need to evaluate this question, but we evaluate this question, we first take note of the kind of problem we're dealing with, but also we think cautiously. Okay, so if you take the limit here, the square is going to be infinity, and then e to the minus infinity is going to be infinity by 1 over e to the infinity. This one here, which is infinity by 0. And this one is called indeterminate. Right, it's an indeterminate form. Now, what is this? The limit as x approaches infinity of x squared e to the minus x. Means therefore now this limit itself needs to be transformed a little bit, and therefore we shall look at the limit as x approaches infinity, and then we have x squared divided by e to the power x. And this gives us the form infinity over infinity, this one here. And we're in a position to use L'Hopital. Right, L'Hopital rule will say the derivative of x squared is twice x e to the x in the denominator. As x approaches infinity, what is the result here? As a matter of fact, right, it is still infinity over infinity. We proceed with the differentiation process, getting 2 divided by e to the power x. And as a consequence, what then we're getting here is that we there have exactly the result. What is the result? Right, so the result becomes 2 divided by infinity, and this is what? It's 0. The correct answer is option A. Any question, input, or suggestion there at hand? What do you think of this? A bit strange. All
Can we
right.
not evaluate using graphs?
Yes, you can use graphs, yeah?
Mm.
Okay, yeah, if you can use graphs, but the graphs are tricky because what would the graph of this one be as x approaches infinity? So you can sketch the graph, right? Okay, so you can sketch the graph of the function x squared e to the power minus x. Right, yeah, but it's a lot of work to sketch this one because now you need to find the critical values, you need to find the things. Yeah, so I would imagine that it's a bit tricky, but it can be done. I mean, if you can sketch the graph, yes, but yeah, curve sketching is very, very technical in general, but it is possible, yeah. If you can have the graph of this, that's close enough, then you'll be able to see that this graph must approach infinity, must approach 0 as x approaches infinity. Okay, so that is sort of the realization you're going to make. All right. Any comment, any remark before we move to the next one, Atlehan?
Yeah, we can move to the next one.
Thank you. Right, here's another one. Consider the following statement. So we have the domain. Okay, we have the domains. Number 1, we're interested in the domain of f of x equals 1/2 to the power x. What is the domain of this? The domain of this. The domain of this. So, okay, here we argue that the domain is this one. Here we argue that the domain is 1 to infinity. Here we argue that the domain is minus infinity to infinity. The question is which one is correct? Yeah, I know you can use graphs. Okay, here we can use some graphs because these graphs are like easy because this is like the exponential function, decreasing exponential, the log function. So yeah, you can use the graphs. But yeah, what do you think of number one first? Let's do it. Okay, but which one maybe you think is the correct answer? Maybe you can do that first. Because A says only statement one is correct. B, only statement two is correct. C, only statement three is correct. D, okay, this is like a section of the exam. Okay, this is like section A of the exam. Only statements one and two are correct. E, only statements one and three are correct. F, only statements two and three are correct. G, right. Statement 1, 2, and 3 are correct. H. Statements 1, 2, and 3 are false. That was H. That's what H means. What do you think? What's your take on this one? What's your take on this one?
Mm.
Okay. Right.
Mm.
Too tricky. Okay,
No.
okay, you can use some graphs. You are thinking of something. What do you think? We discuss it together. Okay. I know that you can get this one right. Yeah? What do you think? Okay, the graph of the exponential function, the first one. Right, the graph of 1 over 2 to the power x. It's like the graph of this function. Okay, so this one is a decreasing function. So it's like this because the graph of y equals 2 to the power x is increasing like this. If this one is the y axis,
from negative infinity to positive infinity.
Okay, that's a good question. Yeah, definitely. So the question is, what is the domain? So the domain here would have to be negative infinity to positive infinity, correct? So, yeah, so as a consequence, then you're able to see that the first one is incorrect. So in other words, this interval here given is incorrect. What do you think of number two? What is the domain of this one? Would the domain of this one be 1 to infinity or minus infinity to infinity? Your take, your thought here. Your take. Okay, it's a tricky one, this one. But you need to just have an idea of the log graph and how the log graph looks like. Okay, if you look at this log graph, how will the graph of this function look like? So first, you need to imagine the graph of the log, the ln of x, right? So if you look at the graph of ln x, okay, this one will be the graph of y equals ln x, okay? Now, if then in mathematics you perform a transformation of that, and you then say the x is made negative, you make x negative. What kind of a transformation is this? So if you have a point on the function xy, and then now you perform another transformation like this, such that the x becomes negative. So what then happens to the overall function? Right, so what happens to the overall function? What kind of a graph is this? It makes a positive x, negative x. It makes positive x, negative x. So this kind of a graph is a reflection in the y. Right, so the graph is going to be sort of like this. You're going to have a graph that is like that. Okay, now, if this is true, then now you perform another transformation of the graph. So if this is the graph of the ln of minus x, so what then would be the graph of, okay, they said very interesting questions for you guys there. And they want to get you guys to think. And this is very, very brilliant. But then the question is, what is the graph of 1 minus the ln?
Is it not
Yeah. Your take on this one? Okay, because remember, these are like past exam questions, past exam questions. Right. So what would you think is the result of these here? Right, so you'd have exactly that part there. So you'd have that. So now in the end, now you therefore have to transform this graph. So if you look at the graph of this minus x, so the graph of the ln of 1 minus x is the same as the graph of minus x plus 1. Okay, so you take this graph of minus x and then plus 1. What does plus 1 do to a graph? But also now you need to realize that this is like a very tricky question. So this is like f of x equals this. So f of x is the ln of that, ln of minus x. So if you want to perform the transformation here, so this one would have to be, for instance, there x minus 1. So x minus 1 is going to become what? It's going to become the ln of minus, and then the x becomes this. Okay, so look at this one. Look carefully. So that is what you're going to have. Right, so if you have the ln of 1 minus x, so now it means therefore you'd have the ln of, you multiply by negative here, which is going to be minus x plus 1. Okay, I'm saying this because if you want to find the actual thing of the graph, yeah, you consider the upper part of this. Okay, so yeah, this performs the kind of transformation of the graph. So if you look at this, it's like this. So this means that you move the graph 1 unit to the right. Okay, because now this is the graph of the ln of minus x, meaning it cuts here when x is minus 1, because when x is minus 1, you put it here, it becomes minus 1 by, it becomes minus times minus 1, which is the ln of 1. The ln of 1 is what? The ln of 1 is 0. Okay, so yeah, so this is the thing. But now this graph then is going to move 1 unit. So it is here now, it's going to move 1 unit and it's going to be sitting here. Okay, so if the graph is going to move 1 unit to the right, because you're minusing from x, so it's going to move 1 unit to the right, and then it's going to be doing something like this. Okay, I'm just using the graph. But the question is, what would the domain of this one be? But look, if it is sitting here, the domain is gonna, okay, if it's sitting here, then the y-axis is an asymptote. The y-axis is an asymptote. But now, which is the line x equals 0, is an asymptote of the graph. So now, which is x equals 0, if then you move it to this side, which means at this point, there is x equals 1. Because if the graph moves by 1 unit, because of the fact that of this 1, then it means that the asymptote is going to move also, because it was like 1 unit away from here, 1 unit away. So the asymptote is going to be 1 unit away. So if you are at the origin here, it's going to be 1 unit away. So it's going to be at 1 here. So what is that? What is the domain of this? So will the domain be from minus infinity to infinity? No, it can't be. Okay, because we're speaking about the domain of this. So what do you think then of this particular question? So, okay, you look at this question and reason very, very carefully. So in the end, would actually be in a position to then say the following. Remember that this question is asking for the range. It's asking for the range. So number 3 is asking for the range. So indeed, the range is correct because it's going to go plus infinity minus infinity. So it's correct. This is the range. So the range is correct. But, okay, but it's asking two things. The domain and the range. So you are able to see, therefore, that at this point, you think the domain is 1 to infinity. So the domain cannot be 1 to infinity because this is the graph. So the domain is going to be what? It's going to be from minus infinity to 1. Something like this, from minus infinity to 1. So which means, therefore, this one is incorrect. Okay, now here's the domain from 0 to infinity. The domain from 0 to infinity, this one here, is also incorrect. So which means, therefore, that number 1 is incorrect, number 2 is incorrect, number 3 is the correct one. So which one is the correct option? It's C. Only statement 3 is correct. So end question. So the correct option here is part C. What do you think here, Aklahong? What do you think of this question? This is like a past exam question. It was like 2022, but I think the guy discussed it in 2023, Bron.
Mm-hmm.
Yeah. You have a suggestion or a question?
No.
No. Thank you so much, Atlahang. We move to the next point. Okay, have you done integration yet?
Yes.
Okay. I'm giving you like 2 minutes. 2 minutes quickly. I know you're not practicing all the time these things, but yeah, you try it, and then when you're done, please you let me know, and then you can discuss it.
Okay.
Right, good. All right. Then we discuss it. We discuss it when you're done. We discuss it when you're done. Okay. Right. And then you'll share which answer you think is correct. Is it A or B or C or D or E or F? You share your input. Yeah. You share your input. It's all practice, practice, practice. Practice makes perfect.
Mm-hmm.
Good. And then you'll advise us about tomorrow's time. So you let us know on WhatsApp what time is ideal tomorrow. That we can have a 2-hour lesson. Yeah. Okay. Right.
I think the correct answer is D.
Okay, that's fine. We take a look. We take a look. We take a look. Right, a couple of things you need to take into account. Now, for us, if the degrees are the same, if the numerator is a higher degree, we perform division. So you're going to say x squared, you divide by x squared plus 1. So x squared divided by x squared is 1. X squared, and this is x squared plus 1, which is this. So you have this one here, which is exactly this. So in the end, we have x squared divided by x squared plus 1 dx. Right, so which is 1 divided by that 1 dx. Right, and then now obviously you can perform the integration of the 1 and then the integration of the x squared plus 1 dx. And what is the integral of the dx? It's only x minus the integral of 1 over x squared plus 1 is the arctangent. So it is arctan of x plus c, and therefore the correct answer is x minus arctan of x plus c. Okay, now the arctan can also be written as the tan to the power -1 of x plus c, so that the correct answer is B, x minus arctan of x plus c, and that is the correct answer. Any question? Okay. Now, in this instance, we'll state a couple of things there at Lehong. What do we state? We're going to state that to integrate this one here, which is x squared divided by x squared plus 1 dx, we would have that another student can come and say, we can add 1 and subtract 1 from this, and then we have x squared plus 1 dx, and therefore this is actually x squared plus 1 over x squared plus 1 dx minus 1 over x squared plus 1 dx. And therefore this one is the integral of the x minus the integral of this one here plus 1 dx minus x arctan x plus c. Okay. I mean, you can do it without using what you call the division algorithm. Right. So in which case, therefore, the student can use what you call the division algorithm. Okay, the division algorithm, or what you call the long division method. Can use the long division method, but you wish not. Let's not use the long division method. Right. So you can use the long division, or you can use synthetic division. Right. Something called the long division method. Right, so can you use the long division method to perform the division? If not, you can just say, oh, in the denominator we have x squared plus 1. Then what we can do is we can add 1 to the x squared in the numerator and then subtract a 1. And then now you perform separation of this. The x squared plus 1 divided by x squared plus 1 produces a 1. And then we have minus 1 divided by x squared plus 1 dx. And then you get the result. You get the point. Right, so any question, any input, any suggestion here, Tehong? Anything you want to add or remove?
No.
Nothing. Next question. Okay, let us look at question 10. Question 10 looks so tiny, but it's about vectors. So we're dealing with vectors. Right, now dealing with vectors, a couple of things we need to take into account. Suppose V bar is the vector with starting point A with coordinates 1, 2, 3, end point B with 3, 6, 7, with length, magnitude of V. Choose the correct option. Right, so, but note that V is a vector with starting point. So the examiner is saying, hang on, there is a vector with starting point this and end point that. Okay, let's do this nicely. Want to have a scheme here and a rough sketch. There is a vector with starting point. What is the starting point? It's 1, 2, 3. What is the end point? The end point is B with the coordinate 3, 6, 7, like so. Now, if this is good news, right, what then is the next step? The examiner is then saying, vector V is the vector like that. So here is vector V. It is the vector with starting point this and end point that with length. Okay, this is the length of the vector. Length of the vector, the magnitude of the vector V. Choose the correct option. Which one is the correct option? Is it A, B, C, D, E, F, O, G? Or neither? I'm giving you like 2 minutes quickly. Right. And then you share your input. You share and be like, okay, what is the answer to this? And then we take a look together. And then we take a look together. Right. We take a look together. Right. We take a look together here. Right. So, right. You have 2 minutes quickly there to finish this one. And then when you're done, please just alert us and then we can help you. Okay. Because this is the aim to learn. This is the objective to learn. It is the objective to learn. It is the objective to learn. Right, so it is the objective to learn. Right, so please advise us here and tell us what is exactly necessary. Right, please. How far?
Almost done.
Okay, thank you so much. Thank you so much, Lebohong. Actor Hong, excuse me. Right, so yeah. Right. Right. So we have exactly that. We have exactly that. We have exactly that.
I got B.
You got B. What did you get B to be the Otlahong? Oh, you got B as the answer.
Yes.
Okay, good. Let us check together. So first and foremost, you're going to actually be able to look at the vector V. So would say the vector V is actually from A to B. B is 3, 6, 7. A is 1, 2, 3. You subtract these things here, which is 3 minus 1, which is 2. 6 minus 2 is a 4. 7 minus 3 is a 4. Then now, we actually, therefore, would be able to get this vector, but it's not the only way to get this vector. So you can always do it like that, or you can say the vector V can be seen as BA, and then if you do BA, it's going to be the negative of this, right? Because you're moving, if you move from B to A, then you would then say A is your final point, then you have 3, 6, 7, and then you would have here 1 minus 3 is minus 2, 2 minus 6 is a minus 4, 3 minus 7 is a minus 4. Then you would have the length of this, right? So the length of the vector V is the square root, right? So it will be 2 squared, 4 squared, 4 squared. 4 plus 16 plus 16. What is 16 plus 16? It's actually 32 plus 4 is actually 36. And 36 becomes 6 units. Okay, this gives us the length. So, yeah, the correct answer would have to be exactly that one there. So you'd have, okay, yeah. So there are 2 possible options so far. Either A or B. So the correct answer is going to be exactly what? It's going to be exactly option A. Why? Because strictly speaking, we're moving from A to B so that A is the initial starting point, is A. The end point is B. So if you are to look at the vector V from A to B so that B is the final point, 2, 4, 4. The length is 6. The length is 6 units. So yeah, what is your take here, Atlang? So strictly speaking, the vector AB would be the 2, 4, 4 with length 6 units. But this one is going to be in the opposite. It's going to be like vector BA. We don't love it. We don't love that one. Okay, yeah, but the correct answer here is going to be exactly that. Right, so your take here, please. Right, so we have exactly these here as a matter of fact. As a matter of fact. Right. As a matter of fact. As a matter of fact. As a matter of fact. So we continue right now to do the next problem. Okay, 11 is the next one. Given h is less or equal to f of x, less or equal to sine x out of 2x, for all x, an element of the interval infinity to 0, union 0 to infinity, consider the following statements. If we have that the limit of h of x is 2, then their limit of f of x as x tends to 0 is 2. Okay, yeah. Which one is the correct answer here? I'm giving you like 2 minutes and then we're going to discuss it. Like 2 minutes and then we're going to discuss it.
Okay.
Right, good. Good. Right, so we good, we good, we good. So you let us know when you're done and then we're going to discuss and then mark these particular questions. Remember, this was section A of the exam, and then we have section B of the exam also. We're going to discuss today. Depending how our time is going to go, so we could do like a little bit of this. Right, so yeah, when you're done, please let us know. 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 Okay. Right. 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 So we have exactly that. Right. So we have exactly that.
This is the challenge when I was getting me to do it. So no matter how impossible it feels, I have to do better because I can't allow myself to fail.
Right. How far?
Almost done.
Okay. Thank you.
Seeing the doctor for the experience, I've gotten rid of any back in the house.
Right.
The only option I always do because I'm only keeping it. But I can't relieve myself in the thinking. I'm a strong, thinking I am. So I can't do. I'm making sure I know how much is in everybody. I don't have carrots, which have 90 calories.
Right. So y'all, please let us know when you're done.
95. And I'm not letting myself go over one single calorie of 1,200 in a day. I feel good in the population, but it just sucks. Amazing. I know it's understand. So I am 100% committed.
Let us know when you're done.
I never would have thought I'm capable of sticking to the guys.
Okay. All right. Please let us when you're done, Atlehang. Okay, thank you.
I know I messed up, and now I have to fix it. I'm making sure I do that.
Right.
I'm starting something new today that's completely foreign to my way of life.
I think number 3
You
is
think number
correct.
3? Okay, let's check quickly. Let's check quickly and see what answer we're getting. If you think number 3 is the correct one. Right, first things first. We are effectively saying in this particular question here, H. So now, what kind of a theorem is this? What kind of a theorem is this? Okay, right. So now we are then saying, given that this is the case for all x, consider the following statements. So this says the limit of h of x is 2. Okay, if the limit of h of x is 2, then the limit of f of x is 2. Right, so you're able to see, therefore, that at this point, if you look very, very carefully, this one would be incorrect. Right, it would be incorrect because if the limit of h of x is 2, it would not just mean the limit of this is actually 2 as such. Next point, because whatever you're having here is you can use the graphs and say there is the greatest of the functions, which is sine x over 2x. And then you have another one a little bit below where f of x is smaller than that one. And then now you have this one here where h is the smallest of all the functions. Right, h is like the smallest of all of them. So at this point, you are actually able to observe that if the limit of this is 2, it does not mean that this is actually 2. Now, in the second case, if the limit of h is 1/2, then it would mean the limit of f of x is also 1/2. So that will also be incorrect. It will also be actually incorrect. So in the end then, right, so in number 3, you'd be saying this limit here. Right, so this limit here. So that would then mean at this point, the limit as x tends to 0 of the sine of 3x out of x. Okay, yeah, you can use anything. It's actually the limit as x tends to 0, 3x over x. You multiply it by 3 out of 3, which is the limit as x tends to 0 of sine 3x on 3x. And this limit here of this one is times 1, which becomes 3. So indeed, this limit is 3 there. This limit becomes 3 there. Right. So you have exactly this part here as a matter of fact. And strictly speaking, therefore, the correct option would have to be C. That is the correct answer. Yeah. What is your suggestion here, Atlahang?
I have no suggestion.
Okay, that's fine. We're discussing, but the very correct option would be 3 there. Would be 3 there. Okay, so we move to the next point. We move to the next point. We move to the next point. Try number 12. I hope you're able to see it. It is the limit as x approaches infinity of 8x cubed. And just writing big 5x squared plus 2x minus 3. This is divided by 1 minus 2x cubed. Right, so look at this and think. Look at this and think. I know this one you're going to do it very quickly. Right, so that in this, yeah. Right, so please let us know
Okay.
when you're done. Right, right.
I got my answer to be -4.
You got the answer to be -4. Very well done to you, and that gives option what? That's the correct one?
A.
Well done. Yeah, that is brilliant stuff. So that would actually be the correct answer. So the correct answer in this case is exactly the fourth one. And therefore, the correct answer is exactly number. No, yeah, it's A. It's A. All right. So we're good. Because now to do this one, you would have the limit as x approaches infinity. You divide by the highest degree, which is x cubed, which is 8 plus 5 out of x plus 2 out of x squared minus 3 out of x cubed. Everything is divided by 1 over x cubed minus 2. Right, as x approaches infinity, these things are going to be 0, 0, 0. And then you have 8 divided by minus 2, which is what? A minus 4. Okay, so the consequence then, you saw right there, Clearhong, and therefore the correct option would have to be A. So the correct option is A, which is actually -4. Okay, so we move to the next point. We move to the next point. All right. See now? Okay, now section B is about the evaluation of this. Evaluate the integral by interpreting in terms of areas. So if you look at the integral from 0 to 3 of 1 plus the square root of 9 minus x squared dx, what do you think is the correct answer to this? Please try it. And then when you're done, you let us know and then we'll discuss it. Now we are starting like section B of the exam. Okay, we're discussing just some integration techniques. Just some integration techniques. Right, just some integration techniques. Just some integration techniques. Just some integration techniques. And then please, when you're done, let us and say, hang on, I am done, done. And then we'll discuss it together. We will go through it, y'all, together. We're just discussing these things and then we shall be, discussing. Discussing, discussing, discussing. Discussing, discussing, discussing. Right. Let us know when you're done.
Oh my God. Right now, I see the first time and then feel absolutely amazing.
I got the answer to be 3.
Okay, good answer to be 3. That's awesome. That's fine. Let's take a look. We're gonna take a look and see what we have here. We're gonna actually take a look and see what we get. Right, so now with the concept of using areas, we have the following. We have the following. Okay, now the couple of things that are very, very central to our discussion here, and what are the central things to our discussion? They're the fact that you need to evaluate this particular integral using the notion of areas, but also the notion of areas is a very, very important notion. So what then you're going to take into account, it is the fact that if you have this, you can draw a diagram like this, and then you can look at the graph like this, and then now you can look at this here, and then be in a position to have the following, and be in a position to have the following. So that at this point, this one is -3, and this one is 3. This is the y-axis, and this remains the x-axis like so. Okay, now, if this becomes exactly true, this would be the graph of y equals the square root, which is the upper half of a full circle. Because if you have a circle like this, it is exactly this one, with x squared plus y squared equals 9. And therefore now, if you have this, now this is y and this is x. Okay, if this is true, what then are you able to do out of this? What then we are able to do out of this is that between -3 and 3, this would be the the drawing of the circle, upper hemisphere of this circle. And then now, but we're gonna cut it. Also now we're gonna focus on x. Right, x is gonna be between what and what? Right, so x is gonna be between 0 and 3. Right, so x is gonna be between 0 and 3, meaning that you're gonna focus on this part. On this part. And then if you focus on that part, what therefore would the area of this one here be? Right, so that means the integral from 0 to 3 of 1 plus the square root of 9 minus x squared dx is equal to. So it would mean, therefore, the integral of this would be given as follows. If then you are dealing with this particular integral here between 0 and 3, right, you would then be in a position to then say, for x between 0 and 3, if you have the function y equals 1, because this is going to be like 3 as well. So there is like y equals 1. Right. So if you have y equals 1, and now you're looking at this particular area here, you'd be able to see that this is 1, 1. And therefore, using areas, you'd be able to see that this is like, length by breadth. So you can be able to see that it is 3 by 1, like a rectangle, length by breadth. And then you'll be able to add that to the remaining part of the area. Okay, so if you agree, therefore, at this point, that this here becomes like a quarter circle. So it becomes a quarter circle because a full circle like this is 1, 2, 3, 4 parts. Now, if you consider this is like a quarter, which is 1/4 pi, the radius is 3 squared. And therefore, this is actually 3 plus 9 pi out of 4. Okay, and this is the answer. But this one you can write 4 by 3. So you can write as 9 pi plus 4 by 3. It's 12 divided by 4. Okay, so this one becomes the answer to the question. And it is obviously now, this is giving us areas, and therefore the areas themselves define something very, very important. And we have what we call square units. Square units. Any question, any input, any suggestion on this, Atlehang? Any suggestion on this, Atlehang? All right, good. So we proceed right now to the next point. We proceed right now to the next point. Right, so in the next case, we analyze the next question. What is the next question? Let's check. Find the derivative of the given function. Do not simplify your answer. Okay, obviously this might be looking small to you, but f of x is equal to e to the power x ln x. So f of x is e to the power x ln x. Please do this one quickly. I know it's easy. I know it's easy. Right. So when you're done, please let us know.
Okay.
Right, good. Done, please let us know.
I got the answer.
Okay, what do you think the answer is? Please read it out.
E to the x ln x plus 1 over x times e to the x.
Good, well done, well done. So f prime of x is e to the x ln x. So first find the derivative of e to the x, which is e to the x ln x plus e to the x times 1 over x. Okay. Like this. And therefore, and this obviously becomes the answer. But yeah, do not simplify your answer, so you can leave your answer in this form. It's very enough. You can even put some parentheses around here, and therefore your answer is exactly that one. Any question?
question.
Okay. This one, try it, please. And then we're going to discuss it.
Okay.
Okay, good. Right. Right, your take, please. Right, your take. Right. Right.
I got negative sign into cos x plus cos into negative sign x.
F prime would be first, we find the derivative of the cosine, this one here. And its derivative is minus sine. And we'll leave the interior like that. We multiply by the derivative of cosine x, which is minus sine x minus the sine of cosine x. F primed is sine x sine x. Right, so it's sine x and that. Okay, yeah, so okay, obviously you don't need to simplify your answer. In which case, therefore, you can leave your answer in any of the forms that have actually been obtained, but you can write your answer exactly like so. Right, so yeah. Any question here? No question, right? Too easy. Too easy. Right, let's look at the next one. C. Try C, please, and then let us know when you're done.
Okay.
Okay, good. Please let us know when you're done.
Okay.
Good. Right. So you let us know, please, when you're done.
Okay.
All right, thanks.
I got the answer to be 2x10x.
Okay. Please come again.
I got the answer to be 2x10x.
Okay, that's fine. That's fine. That's fine. That's fine. So obviously to do this particular problem, there are a couple of things we need to do. First things first, we can be able to see that this function f of x can be written as what? Can be written as 1 divided by x plus 1 to the power 1/2, which is x squared plus 1 to the minus 1/2, which means the derivative is minus 1/2 x squared plus 1 minus 3 out of 2, and therefore the derivative becomes exactly what? Becomes exactly 2x there. So you can write it like this. And remember, it is the derivative, and therefore it can be written like that. But yeah, you do not need to do a lot of simplifications, but 2 cancels 2, giving us negative x divided by x squared plus 1 to the power 3 out of 2. Right, so this becomes the answer. Okay, so this becomes the answer. Any question, input, or suggestions, Atlahang?
No.
Okay, that's fine. We proceed right now to the next point. Right, so we proceed right now to the next point. And the next point is this one here. Find the values of x, value of values of x, such that the vectors are orthogonal vectors. So please try that question and then let us know what you've done, please. Right, so try that question and let us know when you're done. And let us know when you're done.
Okay.
All right.
Yeah. So I thought that. Oh, and then the TV show, you know, okay. And then the same thing. More than 600 pounds. Yeah, yeah.
Please let us know when you're done.
Okay.
All right.
So I remember I was definitely always in the house. And it was really fun. So that's he was such a person to be around. It never really worry about yeah, we went not like that. Well, I have to when I came in and hey, so they say I really myself to an extent. Yeah. I should have tried harder. Made him. Yeah, who was waiting? Oh, what? Yeah. 36. When I started having dollars, I was walking out the door. Halfway, and it was awful. I can't know. Well, I say, so I was in the hospital and nursing home for over 4 years. Well, and taking our picture. I need free chance. I need a chance. And what about this? But he's only got the big. And now he's. I don't know what I do. I want to have a better.
How far?
Almost done.
Okay, thank you.
So we have to find out.
Yeah, and now what is another how?
Right. What do you think the answer is there, Tlehong? How far?
Most close.
All right, that's okay. Right, as you're close to the answer, we are interested in the answer. Right, and we want to know what the answer is to the question, so that we are able to know in the exam what to do to solve these particular questions here. This is very, very important. Okay, it's extremely important for us to take note of these. Right, it's very, very important for us to take note of this here. Right, it's very important for us to take note of this. So, yeah. Right, it's very important for us to take note of this. Right. So, right. So please think about it. And then when you're done, you let us know that, hang on, I'm done. And right now, then we can discuss exactly what needs to happen here. What needs to happen here. Right. How far, Tehang?
Almost done.
All right. I expect it to be done by now. Okay, so obviously, we need to recall that if two vectors are orthogonal, two vectors A and B are orthogonal, it actually means, therefore, that the vector A, the dot product of the vector A with the vector B is 0. So this is sort of the fundamental definition of what we call orthogonal vectors, okay? So two vectors are orthogonal if the vector A together with the vector B is 0. So in other words, we can proceed to then let vector A be the 2x, 4, and x like this. And we have simultaneously the vector B, which is 3, 2, together with x. Now, so let A and B be that. Then we can be able to note that the dot product is 0, so that we have 2x, 4 together with x. dot 3, 2x is 0. 2x times 3 is 6x, right? So we have actually here 6x, and then 4 by 2 would give us exactly 8, and then x by x gives us x squared equals 0, and this is x squared plus 6x plus 8 equals 0, and we're able to find this, the x and x, so that now you actually need to find the product here, right? So the factors here are exactly 4 and 2 repeated plus, and a plus, which means x is minus 4 or x is minus 2. So this becomes the result. So the question was, you need to find the value of values of x, and therefore we're able to see that therefore x is minus 4 or x is what? X is minus 2, and these become the answers. So any question here, Abraham? Any
No.
question on this? Anything you would like a hint about? Anything you do not understand very well that you wish to understand pertaining the notion of a set of vectors that are orthogonal. So two vectors remain orthogonal under certain conditions, right? Under the condition that the dot product of the vectors becomes exactly 0. Now, this 0 here becomes a number, and it does not, it's not a vector, so it becomes a scalar in this case. So it's something you need to take into account as a matter of fact and move forward with the questions. We move on to the next point. Remember, we're looking at the past exam questions here. Right, the next question is this integral. So we're given the integral of the cosine of the natural log of t divided by t dt. Try this one quickly. Please, as soon as you're done with this particular exercise, let us know so that we can discuss the solution together. We're looking at this section here, and this section is a section on what we call integration. It's a section on what we call integration. Right, please try this quickly. Let us as soon as you're done, and we can discuss the calculations, the steps, etc., of this particular question. Okay, right. All right. Okay. So let us know when you're done, please. Let us know when you're done.
Okay.
All right. Let us know when you're done. Okay. Right, we're looking at this section on integration, and this is a part of calculus we call integration, or it is also called integral calculus. It's called the integral calculus. It's called integral calculus. It is called integral calculus. Right, we're looking at integral calculus. we are looking at integral calculus. Right, very, very interesting part of the curriculum here, integral calculus. Right. Integral calculus. Right. How far? At Lahang?
Okay, I got a sine into ln of t.
Okay, that's fine. We're practicing here. You got sine into the ln of t. And that is the correct answer. Congratulations there, Atlahang. So obvious to do this particular question, the couple of things we take into account, and what do? We let u be ln t. So we let u be ln t, so that du is 1 over t dt. Right, this becomes the integral of the cosine. Now, at this point, we're able to make the observation that ln t is u divided by t. What is dt? T du, t du, it's dt. So t du is dt, t cancels, giving us the cosine of u du, and therefore this is the sine of u plus c. So which means that it is ln t plus c. It is ln t plus c. Right, so that is what you got as the answer, correct. Right, so yeah, well done there for having obtained the correct answer there. Let us move to the next question. Okay, now the next one is this one here, B. Here we are facing the integral of x over x squared plus 1 dx. Please try this one quickly and let us know when you're done.
Oh, okay.
Okay, right. Right, so let us know, please, when you're done. Let us know when you're done. Right, so you let us know when you're done. Simply let us know when you're done.
I got 1 over 2 tan x.
Okay, that's fine. We are practicing and take a look at how we do some of the questions. We're going to spend a lot more time on some of these things. We let u be x squared plus 1. Simultaneously, du becomes 2x dx. The integral of x squared plus 1 dx is x divided. What is x squared plus 1? It is u. Dx is du over 2x. 1 over 2. 1 over u du, which is the ln of u plus c, the ln of, because the integral of the 1 over u is ln u, and therefore the u is x squared plus 1 plus c. And therefore this here becomes the integral which is the 1/2, the ln of x squared plus 1. Any question? So that is the answer. Think about it. Make sure you understand. But once again, I mean, we are discussing here. We're going to send you the recording at the end of our discussion, okay? And then you can watch the recording. Yeah. And then there are some questions we're going to give you as homework. Not a lot, because the aim is not to break you down. We want to build you up. We don't want to break you down. We want to build you up. Right, we want to build you up. We want to build you up. We want to build you up. Okay, you're done, right?
Yes.
Okay, good. Okay, this one was encircled in red ink and whatnot. Okay, somebody put some red ink on it, but it's okay. Right, we have this particular integral of 3 to the power t, the secant squared of 3 to the power t, dt. Okay, that's interesting that the dt was cut out of this. Yeah. Okay, so if this one, please do it. We have like 2 minutes.
Okay.
When you're done, let us know.
I got the answer to be 10 into 3 to the power t.
Well, that is very, very close to that. Very close to that. So, but obvious at this point, the couple of things we need to take into account is the fact that we must remove this one. So we let u. We let u be 3 to the power t. Then we proceed to find du dt. What is the derivative of this one? Right, the derivative of this one is the same as what? It's the same as 3 to the power t ln 3, like this. Okay, so this becomes the derivative of the 3 to the power t, because the base is a constant, so we do not just use the power rule here. We use the chain rule. So the chain rule gives us this. And then at this point, we have du, which is 3 to the power t ln 3 dt, meaning the integral of 3 to the power t the secant squared of 3 to the power t dt, it's the integral of 3 to the power t, which is sec squared. Which is now dt is du divided by 3 to the t ln 3. So we divide this here and you have 1 over ln 3. 1 over ln 3, and then you have here the secant square of u du. Right, and this is 1 over ln 3, like this. What is the integral of the secant of u? This is the tan u plus c, which is 1 over ln 3, the tangent. What is the u? Is 3 to the t plus c. Right, so that in the end then we have the following to say, that this integral here is 1 over the natural log of 3, the tangent of 3 to the t plus c. Any question, any remark, any input on this one here?
No.
No question. We move to the next one. Right, the equation of a sphere is x squared plus y squared plus z squared equals 6x minus 4y minus 10z. The center of the sphere is what? 2 minutes. Okay, please let me know when you're done.
Okay.
All right. Please let me know when you're done. Right. Let us know when you're done. Okay. Right. Right. So, yeah. We're interested in the center of the sphere. I hope the question is clear. Is it correct? Clear?
Yes.
Okay, yeah, because we just given x squared plus y squared plus z squared is 6x minus 4y minus 10z. Okay, and then let us know the answer. Let us know the answer.
I got the answer to be 6 minus 4 and positive 10.
Okay, that's fine. So now, first and foremost, we must do some grouping, like x squared minus 6x. So we put the x's together. And then with y squared plus 4y, you move this minus 4y to the other side, it becomes positive. Z squared plus 10z. 0. We've moved all the other terms there. And then the next thing is we have x squared minus 6x. We take half the coefficient. So with minus 6, we half it. And we square that. But whatever we do here, we must also do this side. Y squared plus 4y. So you have here 4 over 2 squared. And then you also add here 4 over 2 squared. And then you also have the z squared with 10z. 10 over 2 squared. And then you also have 10 over 2 squared. Which means you have x minus 3. You square for this one, becomes the perfect square. For the y terms, you're dealing with this. For the x's, you're dealing with that. For the y terms, you're dealing with y plus 2 all squared like this. For the z terms, you're dealing with z plus 5, you square this. Okay, because if you square all the z plus 5 all squared, it becomes this. Right, here you have minus 6 divided by 2 becoming a 3, and you have a 9, 4, 25. So you have y plus 2 squared. So yeah, you have 9 plus 4, 13. 13 plus 15. What is it exactly? It is exactly a 38. Right, we have 38. What is the center? Right, we're able to see therefore that the center is 3, -2, -5. 3, -2, -5. So to get the center, then you're able to realize that we just take the opposites of this, because in general, the center of x minus a squared, y minus b squared, z minus c squared equals the r squared. So we have the ABC, like ABC. So the actual center becomes like ABC. So at this point, it's going to be 3 minus 2 minus 5. So what is the center? The center is 3 minus 2 minus 5. Like so. And this is the answer. Where's the question? Any question on this? Right, so this is, okay, no question. Right, remember that the recording is going to be sent to you. The next point. What is the radius? The radius of this sphere is what? Please find the radius quickly. What is the radius? What is the radius of the sphere? What is the radius of the sphere?
Is it not root?
Please
It's
come
not
again.
38. 38.
The square root of 38. Good. Because you saw that we had x minus 3 squared y plus 2 all squared z plus 5 all squared equals 38. Giving us radius. Right, the radius becomes the square root of 38 units. Right, become the square root of 38 units. So what is the radius of the sphere? It is actually exactly the square root of 38 units there. Any question? Obviously, I'm sure that you're able to understand that one, right?
Yes.
All right, so yeah, it was awesome having a discussion together this moment. So what we're gonna do, we're just gonna send you the recording of this, and then we shall discuss again tomorrow. You'll advise us on WhatsApp if we can use the same time as today, or you can always change to another time slot. Okay. Any question? Any input?
No.
Okay, nothing. Right. From us, it was awesome having a discussion with you today at Kahong. Right. And we keep in touch for tomorrow. You'll keep us posted about the time that's best tomorrow for you, for us to have our other lesson. But yeah, it was wonderful having this discussion. Have yourself a very awesome afternoon, and goodbye for now.
Goodbye.
Goodbye.